Okay, here we are again, and I am running again. There we go. The mouse is on a cord now. I have tethered it, leashed it while it charges. So we were working on clamp. So where I'm going to use it instead of the min-max is I'm going to say clamp and explicitly minimum maximum values. So now we can robustly say that TWR is always going to be in this range, and KA is always going to be in the range 0 to 1, and CT will always be in the range 1% to 1. Yay! And I just need to use clamp everywhere else. I say max min. Like that. And I could clamp the error fraction as well. Yeah. So angle error is a fraction of max angle error, clamped from 0 to 1, and throttle is clamp from 1% to 100% of 1 minus the angle fraction. Yes, it's redundant. Yes, we could make it run faster. Yes, it could be smaller, but in this case, it means that we absolutely know angle error fraction is in a range. And old habit from embedded software, the more things you can assure that are an invariant between one section of code and another, the better chance you have of building something that actually works. And I have always said that it is possible to write permanent software. So you write a method that does something and does it always and does it well and has no bugs and achieves the goal with no bugs reliably in all circumstances. You can then seal that up, toss it in a library, and never, ever, ever have to think about it again. And now that's a core thing you can use. Like we can use min and max. We don't have to think about how they're implemented. I can now use clamp. I don't have to think about how it's implemented. I could just use it. As long as I've imported POF. I could go so far as to make clamp a part of Farkos, and I'm going to do that. So, Farkos is now going to provide the clamp global method. I am going to do that right at the top. Add methods here that should have been part of the standard kOS library. So I assert that a range limiter clamping a value into Rails should be part of the facility. Now, if we were to allow nans, okay, if we were to allow nans, then I don't know what max and min do in the face of nan. I believe that if you pass a nan to either argument of either max or min, it should be nan. So clamping a nan into a range should give you back the nan. So even looking at that oddball corner, I believe this does the right thing. This also means that if there are, whatever data type is available to max and min is now available to clamp. There we go. so. This is the second stream that I have advertised as being live coding persistent storage. One last shot at getting some funds coming in, and then I'm going to call it, and we're going to go do the actual persistent storage thing. So this has been a couple hours of faffing around trying to get funds. Maybe I should have done this kOS development in a sandbox. I don't know. I think doing it under tell you what, at least the parts of it that are off stream, it's actually kind of fun, kind of chill, just, you know, trying something and either succeeding or failing or making some progress and trying something again. That's actually something I enjoy in Kerbal Space Program. I'm not sure how well it comes through in a live stream. If anybody ever watches this, I'm sure you will leave a comment that tells me either this is great now to be doing it, or I'm lousy. And of course there will be those of you that say, oh, you don't have a voice for this, you don't have a face for this, you shouldn't be doing this at all, grumble, grumble. You guys, yeah, your comments aren't even going to appear in live chat. Or maybe they will appear, maybe they'll go away soon. I don't know. I have no idea how to handle chat or comments in YouTube videos. Launch. So, another try at taking our two tourists to space. Yay, space. And I heard a blip. Something crashed. Open terminal. Yeah. There's the error. And I've moved my keyboard up on my desk so I can stop with the keyboard tray that's so loud. So that error is the new function I wrote. Doesn't even compile. Because I wrote parameter low, comma, parameter high, comma, parameter val, and that's no good. Low, high val. Okay. Trying again. I think I could just toggle power twice and have it go. I am declaring a value, not a function. I need a dot. This is the development loop for kOS. Unexpected token found on line 122 of POF because I wrote the clamp function and I forgot that I needed to take away one close parenthesis. There. I'm glad I load up all of my dependencies at launch time because now I know this works. Launching in 1 minute. There's launch. Whoop. Oh, close. Close. There we go. We're looking a bit wobbly on the control there, guys. I'm wondering if I actually need that RCS unit in there. Tell you what, though, the next ship I build is going to be a much lower, shorter configuration. I will use Radial to set up liquid fuel multiple liquid fuel stages if I have to. I'm starting to think about E configuration, where we've got we've got liquid fuel stacks in the place of those solid rocket boosters. Maybe adding boosters to that configuration, maybe not. Maybe a complete liquid system. I really need larger fuel tanks so that I don't waste so much of my part count on fuel tanks. I really need a better on-orbit engine that's not so big, maybe a little more efficient. That's sounding more and more like that's our next science to open up. But I need science, and I need funds. And damn it, I need to get back to writing the persistent storage thing. So I'll do the persistent storage on the stream, and then off stream I'll just roll around grabbing science and see what I can do. I will grab parts tests that are on the launch pad or splash down and do those. Which means on stream I'm going to want to live code the persistent data, and then I'm going to want to do a stream where I live code the telemetry recording that records the telemetry and uplinks it. So in between there, I'm going to have to do some just grinding to get money in science. If you look closely, you can see the engine bell moving. In fact, let's aim our camera at the engine bell, and we're going to lock our camera view. So we should be seeing the engine bell move around a bit as we do it. I thought I saw it. Maybe it was just the light. So during this phase, we still should be trying to steer. Okay, let's lock our view. Here, where'd it go? Aim camera, there we go. Notice how we had a brief burst when we were approximately aligned, and now we've got a little bit of alignment. I don't think that's enough thrust on this engine to assert attitude control. I am using the swivel engine. There we go. Yeah, I guess it helps. So, yeah, that's as good as we can do for this flight. For the next vessel design, I will need to make sure that I have some attitude control in my capsule area. We're now in orbit. I think I had a fixed delay. Let's go ahead and conduct the materials study. Accept, transfer data to the box, and items stored. There we go. Close doors. And now we're initiating deorbit. So Mattis and Madeline should be happy now. Notice that tourists may not disembark, so the tourists couldn't have done any EVA at all. And again, yeah, this tiny amount of thrust is not enough to actually get any decent attitude control out of us. I mean, we've got some. Fortunately, we have quite a lot of delta V available. It doesn't take very much to deorbit. It doesn't take very much at all to deorbit. So I'm not worried that we're going to waste fuel. We're also only burning at 1%. But come on, guys. Get it together. See, we're managing to get some control over it, and it's heading for the retrograde point. So even with just this little teeny bit of thrust, there we go, boom, and there's our deorbit done. So after deorbit, we're just basically going to spin around until we get into the atmosphere. I'm going to go ahead and warp us in. I think aerodynamically, this vessel tends to point in the right direction. Was there a function key I could hit that? Okay, F2 turns on and off the UI. That's good to know. F3 is flight results. 5 is a quick save. Oh, one of these might be a quick load. I don't want to do that. Let's see. Settings. Is there something I can look at my key bindings here? Nope. I remember there was a function key I could hit which would bring up the aerodynamic forces, and it'd be good to have that on hand. Okay, there's retrograde, and we're going to swing past it because we have no attitude control. Let's go ahead and... So at 4x, we still don't have very much atmosphere working on us. Mattis and Madeline are still having the time of their life. There we go. We are decelerating. And we are out of fuel. Now, we can't stage to get rid of this because doing so would get rid of our processor core, which would mean we couldn't pop our chute. So we have to hold on to this configuration all the way down until we're ready to activate the parachute. Now, the parachute does have a altitude and minimum pressure that are configured in, so maybe I could get away with popping it early, and maybe it wouldn't. Maybe it would work, but I am not sure about that. Let's see. Let's set this back down to 1 as we cross 5,000 feet. At some point here, we will reconfigure for landing. Bada boom, bada bing, and boom. So, reconfiguring for landing did not successfully pop the chute. I am going to revert. I'm not going to accept that result. The problem is that in the process of editing this spacecraft, I messed up and I moved my chute into a separate stage. So now the question is, do I want to stop here and put some... Yeah, okay. So for this flight, we are not going to do science. I forgot anyway. So our science bay disappears. So we now have one part to work with. Control. Small inline reaction wheel right there. And And let's go ahead and sink this down into the spacecraft. So you go up. And you go down. So we now have a reaction control wheel in there. The other thing I'd like to do is make it easier for me to access this. We still need all of these guys. So this is going to take up a connection point. I think this guy actually is just going to consume a radial point. So yeah, to get this core in, I am going to need a service bay present to get the extra connection point. So now we have two things that we need. I want that guy. I'd like to be able to clip through so that he's visible. So let's move him. I think, yeah, that makes it so I can attach him from the outside. I can touch him from the outside. There. And now we'll connect him there. And let's see. We're not going to be opening this up ever again. So I can move him downwards. I don't like the idea of him being clipped into the top here, but I can move him down like that. And now I can close this. Oops. And I'm going to clip the fuel tank up. Okay, so he's a little shorter. He'll still be wobbly, but now I can just pretend that's all one unit. I also remember that over time, originally, I got a real distaste in my mouth for the whole solid rocket booster idea. They caused more problems than they were worth. Most of my rockets later on in science will be completely liquid fuel, but in order to get the delta V of one of these SRBs, I need a whole bunch of fuel tanks, and I do not have the part count available for a lot of fuel tanks, so we're stuck until I can get a bunch more science. So 15 science. 15 science is all we need to crack open the next research, and then another 45 after that. So between streams, I'm gonna have to get that science. But for now, we're gonna use Farkos D2 to try to get some funding. Okay, back to our mission log. Let's update our numbers. We still have the same 138.72 funds. And I'm going to log our launch cost. Is going to cost us 17052. This craft costs us 17,000 to launch. That's an important number because our revenue from our little guys here is not much more than that. Okay, what have we done? We have added attitude control, above the ball. We have moved things around a little bit so that we got our 30, and I don't have to ever open this again because now I can just, you know, access the SCS directly if I need to. We have there. These need to be on the same stage. So the same stage that cuts the ball loose has to also pop the chute. The other thing I want to do here is I'm going to modify here. So popping the chute is going to be done whenever, because the chute itself, we're prepping the chute to go. Chute is just going to say, we're done. So we call for the chute, it's going to go and just do it. So no max altitude, no speed. The chute itself has logic for that. We are going to reconfigure immediately for landing. Which means extending the landing gear, unlock steering. Well, none of this is going to matter. We're going to gear on, wait until stage ready, and stage in an infinite loop. Because, and this is important, there's a stage number. I could wait until the stage number is low. I'm going to adjust this. I'm going to get out on the pad and interrupt this real quick, and I believe it's stage : number. No, let's look it up in the manual. So stage. Stage : number. Until stage : number is less than 1. I'm not sure if that's the right thing. Let's try this. I think reconfiguring for landing, this should stage us down through 0. If it does 2-0, we're broken. So let's go back to this. And I'm going to just immediately do a chute at the beginning. And then wait until false. And let's do that here. This is going to be a disaster, but it's a disaster that we are selecting. Oh, I didn't show it. This is what I'm doing. Turn off Emacs. I'm basically going to say shoot now, like this. And the change I made to shoot, which I forgot to show, was I've deleted most of it. I'm just saying reconfigure for landing, gear on, and until stage number less than 1, wait 2 seconds and stage. So we're going to stage every 2 seconds until stage number gets down to 0. And I want to find out if we actually pop the chute at that point. So this is a test launch. We will be reverting. I thought I could. No, that's the P. Okay, so I can't actually select. Yeah, okay, so I can't actually select the control module from here. That's fine. I'll have to make it stick out from the bottom of the P a little bit. So 2 seconds per stage. Bad idea. Revert flight. Okay, so we couldn't even test it because of what it was doing. That means that I am going to need to test my chute at a different layer. Means we need to launch normally. I'm going to comment out everything else. And after launch, I'm just going to wait until max thrust. So once our solid rocket boosters flame out, we'll be able to do our shoot test. Oh, and I need to modify this so I can actually get my hands on the guy here. Open here. So, moving things. You move down a bit. Well, that should be good enough. I didn't even really need to open him. I'm so glad I can actually clip parts. Damn it, half an hour in, I haven't even started on what I said I was going to do. Yak shaving. Lots and lots of yak shaving. Focus. Okay, so solid rocket boosters have to clear out before we can test to make sure our new parachute stuff is right. And that fails. It's ship : max thrust, not max thrust. Oh, come on, Greg, get your hands on the right keys. Okay, open the terminal so I can see the terminal while it launches. Then time warp forward. So again, launching, getting rid of our SRBs, staging down to see if our chute will actually pop the chute for us. Parachute is configured. Damn it. Get suffix max th thrust. Fixing the typo. Revert to launch. So this is still under the control of the launch program, not on the ascent. So this is just going to continue with whatever steering I left set up at the end of launch, which is fine. It's fine. There we go, and that popped the parachute. Even though we were way too high, we were not too fast. Now the parachute is actually configured by pressure, so as long as the air pressure is low enough and the speed is low enough, I am perfectly fine with this. So this is a good configuration. We're going to revert flight to launch to vehicle assembly, and let's undo my edits to the thing here. I know there's a way in VS Code to comment out a block of code. There we go. And I am confident the chute is going to be good on this one. Dunk, dunk, dunk. Save, and we're going to launch, and I am going to walk away from the keyboard shortly to go get something to eat. And this launch is just going to happen. And I am wondering if I should cut the VOD and... No, let's surface forever the fact that when Greg says he's going to do anything, he can end up yak shaving for half an hour before he even starts, and this is after a 2.5 hour stream where he never got anything done on it. So that's going to launch, and it's going to do the whole mission without me even at the keyboard. So I am way away. I can tell by the sound that we are on our ascent path. At least I hope we are. I'm not seeing our path right now, but the engines are continuing. Okay, there's our stage. Kerbals are flying, I'm grabbing a quick snack. I am really hoping we're actually following our pitch path. Like I said, I am not at the keyboard at the moment. Not watching the screen at the moment. Okay, so we should be into our final stage here. And there's Miko, and I am back. What does it look like? We have our apoapsis is 72 kilometers. We are coasting up. We have 1,500 meters a second of DV, so that's good. It should take us about 1,000 meters per second to circularize. It should take about 50 meters a second to deorbit, and the rest of that can be dumped into deceleration. I'm going to turn off the camera while I eat. Notice that this time, as we're approaching our orbit during our coast up, we are not tumbling. So that reaction wheel is working perfectly. How are we doing for fuel? Well, we see that our electric charge is actually holding pretty steady, which is good. And as we burn this engine, it recharges us. So we're good. And we're going to get circularized here. There we are. And there's our deceleration, our deorbit. It was just a tiny bit of fuel brought our periapsis down under 20 kilometers. And that leaves us with 669 meters per second of delta V, which we will apply fairly high in the atmosphere. And if my scripts are working properly, it should then stage us through, activate the parachute, which shouldn't actually deploy until, let's see here, 4% atmospheric pressure. Oh my. So altitude is the altitude where it spreads. I think I don't want this to pop this soon. Yeah, I want to wait until it's low before we pop the chute. So Mattis and Natalie are looking a bit nervous there. They're happy now that things have been deployed. Our parachute is active. It will deploy when it's safe. I think I need to not warp. Is that right? So we're just going to chill for a bit while this comes down, and we'll see what happens with the parachute. Now, while we're actually doing nothing in game, I can get started on this task that I have been putting off, because I am fairly certain that this code is going to be correct. So, first step is I'm going to commit what I've got here. Debug Farkos-D/2. So we made some changes. Oh, that was in-stage changes already. Hold on. We can look at our changes if we want. I'm not going to even look at the changes. I'm just going to check in what we've got. So of note, added clamp, low, high, val to have a value to within a range. Okay, so we're done with that commit message. And go over here, and I'm going to do this. Start working on this issue. Okay, all that noise was from stuff we dropped landing, and now we can look at this. It should be exciting. There's our parachute. And it popped when it was safe by design. And we did manage to get it opened out before we hit the ground. Yay! Vessel recovery. So no real science to speak of. I mean, some from getting a vessel back. So we recovered 2,080 funds. And afterwards our funds are 269,100. So what else did we get money from? Well, those would be the contracts. Our tourists have advanced to level 1. They're ready for their next assignment. Well, we've completed their contracts. So we look at the archives and we see that we finished the complete orbit Kerbin. So orbiting Kerbin netted us 31,200. And tourists. It does not show us how much I earned. I should have written down what was in the contract before I started it. Oh well. But we can compute it because I can say we add up. So 269, 100 minus 130, 872 plus 17052 minus 280 minus 2. See 1200. So I think that was 122,000 for the. That's not right. That can't be right. I am not sure how those numbers work out. But we now have 269,000 funds, which is enough to upgrade. Yay! It's enough to upgrade our launch, our VAB, so we can make bigger rockets. And following that, we will still be able to have enough money to launch another. Yay! Okay, so what are our next things? Explore Kerbin. Wait, these guys only wanted suborbital. I could have done that with a smaller rocket. Okay. I am going to build a suborbital rocket next, just so I can do these guys. But first, let's do this one. No. I need to stop. I need to work on the piece of code I said I was going to work on. So we have a contract to... We will get a contract to do a spacewalk. Expires in 3 days. I believe this is one that is always there until we do it. And the other one is Ferry 3 Tourists. It's a duration of 5 years. I'm going to accept this. I think I need to fly this Explore Kerbin immediately. Because 3 days is not much time. So I'm going to take the flight we just did and I'm going to repeat it. So this is going to be another D2 launch. I'm not even going to go for a D3. This is going to be a D2 launch, and all I'm going to do is just do an EVA so I can get that done. And maybe take one. I'll take one of the tourists with me. Yeah, I can knock off those 2 contracts. Okay. Greg is going to procrastinate again. Okay, so I want to take one of the tourists. Jeb's going to get himself some EVA. The tourist only wants a suborbital, so I can do a smaller spacecraft. I could put him in a C spacecraft with a thing. I could do a smaller craft that's just suborbital for these guys, but let's take him up with me since I'm going anyway. Actually, rather than design a new spacecraft, I'm just going to do 2 launches. So I'm going to have a short time on orbit to get Jebediah out there on EVA and back. what I can do is, knowing that this is going to work, I just have to be heads up when we get to orbit. So we are going to persist data across reboots. This is going to be a new package, so it's not going to impact the current flight. We should be on a new branch. Pause a second while I deal with a cat. Okay, we may be doing cat battles along with this. I have given her a hug, and I put her under a blanket, and she immediately went to the kitchen, so we'll see what happens. So, this log did not get saved. Hold on. I have a better Git tool I can use. Hold on. There we go. Okay, so now we should be in a branch for the new code. And I do need to keep my ears open because, yes, we are about to be on orbit. So, let me get Cheva's EVA really quick once we get to orbit. We're going to go EVA and grab an EVA report from somewhere, we don't care where, and get back in, and that'll be all we do. EVA report. 8 science, not bad. Okay, he's done. So now everything for the return is automatic, so I can focus back on reading code. Oops. So here's this. Source code control should say branches. We are on issue 4. Let's take a look at the issue. Whoops. Apparently that little check mark says stop working on it. So I can look at the issue in the browser but not in Visual Studio. That's too bad. So go back to the code, and I think it might be a good thing for me to write a README file about this along with, well, let's see, let's actually put it in the source code then. So new file, we want to persist data, call it persist.ks. Persist.ks is going to be a module. which means we're going to do that. We're going to say export something. And I'm going to have a lex, which is going to have several things in it. So let me bring the requirements into the document. So surely there is a way in Visual Studio for me to comment out all of this. It's not a refactoring. My wife has brought me lunch. The apple I had is nice, but it's not full lunch. This is full lunch. So my best bet here, because I am not competent yet in VS Code, would be either to look up the documentation or bring that file up in Emacs and do in Emacs what I wanted to do. So here's the commentary from the task. So a method exists to assure the current vessel storage is persisting the current values of all persisted data. So this is sync. So we're going to say function sync. And I'm going to want Farkos available. So for now, well, the function exists. We haven't figured out how we're going to do it yet. So right now, I'm just going to say Farkos :ev stub persist :sync. A function exists for a module to set a value for a given name. Function is recorded to vessel storage. So we're going to say function set. Parameters are going to be name and value. Farkos :ev stub set name to value. And these values may be lexicons, so yeah, this might be more text than we want, but for now, it's good. A method exists for a value to determine if a value has been saved for a given name. We'll call it has name. Return false. Okay, and for those of you that are noticing that I am writing just the minimum stuff, no, I have not completely eaten the red pill for test-driven design. I am not going that direction. No, thank you. But some parts of it are good. That is, I am writing just what I need for this, and we will expand it later, because otherwise I will not be able to keep my context. A method exists for a module to retrieve the value associated with the name. So we need to take the name and a default. Farkos. Come on, Greg. Stub persist :get name default. is return default. Using a value that is not serializable is a coding error and may cause the kOS program to crash. This is a warning that I want at the top of the module. So let's patch this up a bit. Okay, so for now we're still doing nothing there because I don't know what I want to do yet. It's a good thing I have documentation. There we go. So there's our initial setup. So we're associating a name value. That's a lex. So we're going to say local persisted. Let's just call this pmap. It's persisted is lex. So to set, what we do is we say persist add name value, and that should be the whole thing. Return persisted has key. I need to bring up the documentation for lex real quick. Lexicon. Has key. So that's done. Get. If I think there's a ternary operator in kOS called choose. Oh, and we're almost landed in KSP there. Oh, I haven't been showing my coding. Oh man, the whole point of this was showing the coding. Okay, so basically I started by blasting the comments in, and then I made functions that just stubbed, and then I changed the comments about the functions to just be documentation rather than worded as a requirement. Went in and set up a lexicon. So here's how we add it. Check for the key, and here's how we're going to do the default. I do need to look at the choose ternary operator and see if I want to use it real quick. So choose expression 1 if condition else expression 2. So we're going to choose, and expression 1 is the normal value. This will be persisted of name. If persisted, if has name, else default. There we go. So now we have this lexicon. Other things I want to do, when I set, I want to sync to assure that I've written it out. And now I want some way of loading up the value of persisted from disk if it's not there, if we, during our setup. If it exists on disk, I want to load it, and then sync needs to write it. For that, we'll use JSON. And I'm bringing that up in documentation alongside. So I can, for sync, write this. Write JSON of my persisted lex, and it needs the value. So I'm going to call this I'm going to give it a name up here. Now I need to have access to my home directory from here, because I'm going to want to copy this to the archive as well. But nothing here said archive, so we'll worry about that as an extension. So there's the right JSON. So the other part of it is I want to load it up. And I need to do that when I am importing. So read JSON should give us back the lex, but I only want to do that if the file exists. I believe that's correct. So each time we do a set, it's going to do a sync. So the lex down here needs to export all of our things that we defined. So that is sync, set, has, and get. Okay, so there's the code. I want to test it. Well, before I do that, we've got code here that should work. Let's finish up this mission here, and I'll start the other mission going. I'm going to start the other mission going and get some lunch, and I will cut the VOD and start a new VOD after I've had some lunch. In fact, I will do some debugging off camera, verify, write some tests. It's kind of outside the scope of this. So, yeah. I'm going to declare it outside the scope. So we do a recover. So we did that, do our EVA thing. We got some science. We took a tourist to orbit who really only wanted suborbital. What did we get? We now have 71 science, so we're chunking right along on the science. That's good. We got 2,000 left. We're up to 320,000. I am not sure what's going on, but I think we're getting more funds than I thought. And there's crew. So yeah, let's stop the stream, and I will run the other two tourists up off camera and have some lunch, and we will resume later.